Okay, so this is the example from last Friday. I was asked to just go through an explanation, so I'm going to quickly go through it for anyone that's not understanding anything about it. So we're told if y equals sine 3x squared, find dy dx, i.e. differentiate this, and then hence find the integral of 6x by 3 cos 3x squared with respect to x. Okay, so if we first find the derivative, so dy dx, when we want to differentiate this type of a trig function, well, the trig function become the derivative of the trig function sine is cos. So sine 3x squared becomes cos 3x squared. And that gets multiplied by the derivative of the angle, the derivative of 3x squared being 6x. And you can tidy that up and it becomes 6x cos of 3x squared. Okay, that's our dy dx. Second part of the question then says, hence find the integral of 6x cos 3x squared with respect to x. And you notice that the integral we're finding is just the same function as the derivative. Now remember, integration reverses differentiation. So for instance, if I have a function y equals 3x squared, then dy dx of that will be 6x, but the integral of 6x, where you add 1 to the power and divide by the new power and add in your c, will bring you back to the original function 3x squared plus c. So differentiation and integration are the exact opposite of each other. We're doing indefinite integration at the moment, so that's why we have a plus c in case there was a constant there that we didn't know about. So since integration reverses differentiation, if we want to find the integral of 6x cos of 3x squared, well, it's just what the function was before it was differentiated. And in which case, we know up here, this is the function we differentiated. So therefore, the integral is sine of 3x squared. We have to add in a plus c, just because we don't know if there... We do, I suppose, in this case, know that there wasn't a constant there, but in other cases, we don't know. So we add in our plus c. Now, there is a way of integrating something like this without having to find a derivative and go back again. It's called integration by parts, but it's not on the course anymore, so we don't need to do it. So if a question like this comes up, it will always be phrased in this way. Okay, I hope that helps.